Section 2.2, Solving Inequalities Using Addition or Subtraction. Most inequalities that we've seen so far are already solved. What we're going to look at today is just very simple inequalities that require one step to be solved. And we solve them oftentimes just like we do with equations using inverse operations. So for our first example here, we have x minus 6 is less than or equal to 12. We know that to solve an equation, we would isolate the x, and that's exactly what we want to do now. In order to isolate the x, I'm going to have to take care of this negative 6, or this minus 6, by adding 6 to each side of the inequality. Now when I do that, I'm left with the statement x is, I keep my less than or equal to, and 12 plus 6 is 18. And now that's my solution. That's a one-step inequality, but that's my solution. And I can graph it on a number line. So I'll put 18 here on the number line. I'm going to put a closed circle because it's an or equal to, so I want to include 18 as part of my answers. And I want everything that's less than or equal to 18. So everything less than 18 is on the left, and that all comes way over here. And so that's my graph on the number line. Now the way to check the answer would be to take any number that's over here. So let's pick a kind of a convenient number like 0. Might as well pick an easy number, see if we can make it work. We're now going to take that 0 and plug it into our original inequality and check to see if it's true. So when I plug in, I have 0 minus 6 is less than or equal to 12. And I'm hoping that that's true. Now 0 minus 6 is negative 6, and negative 6 is less than or equal to 12. Well, it certainly is. All negatives are less than all positives, so that's a good sign. And that's as easy as it is. It's just performing one operation to isolate the variable and then graphing our result. All right, let's give you some practice. All right, here are three inequalities to try and solve. I'm going to go through them one at a time, but why don't you pause the video and now try to solve each one, and we'll take a look at the first one first. All right, how do we do? So you can see that what we end up with here is the solution y is greater than 4, which has the graph featured down below with an open circle at 4 and the arrow going off to the right. I used 5 as a test value for my check, and that worked. All right, on to the next one. Go ahead and give it a shot if you haven't already. And here we go. All right, so for this one, we end up getting our solution is right here. G is less than negative 1/6, which is the same thing. Negative 1/6 as a decimal is negative 0.16 repeating. And so that's our solution. We had to get a common denominator to combine these fractions here to do 1/3 minus 1/2. I made 1/3 into 2/6 and 1/2 into 3/6, and then did the subtraction. So we ended up getting negative 1/6, which would be here on a number line, open circle because it's just less than. I don't want to include negative 1/6 as part of my answers. And then I just pick a convenient value like negative 1 to check, and negative 1 plus 1/2 is negative 1/2, which is certainly less than 1/3. So that's our check. All right, one last example. Go ahead and give it a shot. And here we go. All right, and so here we end up getting, pretty quickly here, instead of dealing with any fractions here, we have a nice easy problem. We do have negatives to worry about, so a negative minus something is a bigger negative. We get w is greater than or equal to negative 16. So I'm going to fill in the circle at negative 16 and have the arrow come out to the right. And just pick a convenient test value, something that's easy to work with. That's why I picked 0. It's over here. It's underneath the arrow, just like the negative 1 was underneath this arrow, the 5 was underneath this arrow. That's all we need to pick. And so we pick 0 for our check, and we see that it works. All right, pretty straightforward, I hope. Let's see what this looks like in a word problem. Alright, so let's say that Nolan, this is my son Nolan here, has $18.43 in his piggy bank, and after his birthday, he's hoping to have at least $40 in total. How much money would he need to get to meet his goal? A pretty ambitious goal for a 3-year-old, but that's fine. And so this might seem like an easy problem to do, just do the subtraction and you know what to do. But we want to look at how this can be represented by an inequality, and that's really the key here, is just to look at it in that context and using an inequality. So what we want to think about is what story are we telling here? Well, we're telling what Nolan is starting with. We know he's starting with $18.43. And then he's hoping that he's going to get some for his birthday. So that's an additional amount of money that he'll have. That would be plus X. We don't know what the X is yet. He's hoping to have at least. At least is a phrase that typically means greater than or equal to. That's a really ugly symbol there. Let's try that again. Is greater than or equal to the 40. Because as long as he gets enough to have at least $40, it'll satisfy it. So if he got $40 for his birthday, certainly he'd have enough. And now in order to solve this inequality, we just do a simple subtraction. And that's going to leave us with X is greater than or equal to. All right, so we have a subtraction with a decimal here. So let's do this out. Remind ourselves of how to do this. Basically, I'm going to take that 4, make it a 3, and go 9s all the way until we get to this one. And then we have our subtraction. So 10 minus 3 gives us 7. 9 minus 4 is 5. 9 minus 8 is 1. And 3 minus 1 is 2. So that's what we're looking at there, 2157. And so as long as Nolan gets at least $21.57, he would meet his goal. So if he just got $20, wouldn't be enough. If he got $25, it would be enough. Now for word problems, we want to put it back into a sentence, so let's do that. And so we could write it something like, Nolan needs to get at least $21.57 to meet his goal. You'll see that once again we've used the phrase at least, like we did up here, because we have a greater than or equal to. We could say he needs to get $21.57 or more. He needs to get greater than or equal to $21.57, $21.57 or above. Any of those things would be fine. And just an important note, the dollar symbol goes in front. A lot of people I've seen are putting the dollar symbol at the back. I'm not sure where that comes from. I guess that's just the way that we say it. But the symbol goes at the front of the number there. All right, so that's just a really easy example, but it does involve inequalities, and there you go. All right, just one last thing to talk about. Here, I just want to mention 2 problems that can sometimes arrive if we have even simple-looking inequalities. With this first one, 2 is less than c plus 4. I can add 4 to each side. And that's going to give me 6 is less than c. Now, the warning that I have there is what we're going to do a lot of times is people are going to put 6 on their number line, open circle, and they're right so far, but they see the less than, and they come over to the left. The problem with that is that when we go to do our check and we pick a value that's over here like 0, and we plug that back into our original, we see that something bad happens, more or less. We have our check would be 2 is less than 0 minus 4, which says that 2 is less than negative 4, and that is not true. Right? 2 is not less than negative 4. Well, the problem here is that we saw the less than, so we immediately went in the wrong direction. The problem is we needed to think about what's bigger here, c or 6, and the c is really what's bigger. A lot of times I find it easier to rewrite this inequality up top as c is greater than 6. That reminds me that rather than having this part of the graph covered, I actually want the right side of the graph covered. And now if I were to pick another test value like 8 and plug that in, I'm going to get something that will work. 2 is less than 8 minus 4. That's 2 is less than 4, and that works. So be very careful if the variable's on the right side of the inequality. You get used to thinking less than goes to the left, but only if the variable is also on the left. The variable on the left, as it's written here, is usually a lot more convenient to work with. All right, so that's just one thing. The second thing is with 10 minus k is less than or equal to 12. We're going to subtract 10 from each side. And what a lot of people then do is they actually forget to bring down that negative with the k. They'll bring down just the k and get negative k is less than or equal to 2, but they'll just get positive k is less than or equal to 2, and then they go to graph it. But depending on what they choose as a test value, that might not work. So if that's what happened, let's say they forgot that, and they go to put their 2, and they put a closed circle, and they go to the left, and that graph looks fine. And then they pick a certain value like, I don't know, how about negative 5? And we go to check that. 10 minus negative 5 is less than or equal to 12. Well, minus negative means plus, so that's going to give us 15 is less than or equal to 12, which is not true. Not true. And the reason that it's not true, and the check shows us that, is because we haven't actually solved this inequality yet. We forgot to bring down this negative, so we actually have to make this negative k is less than or equal to 2. In the next section, we're going to talk about how we solve that when there's a negative involved, but just be careful to make sure that you do bring it down. What ends up happening here is we divide by negative 1 on each side, so we're going to get k, and we're going to get negative 2, and actually a rule, and we'll talk about this again later, is we actually have to flip our inequality around. So we actually want to have k is greater than or equal to negative 2 is what ends up happening. And so our graph would be very different than this. We wouldn't have this part. Our 2 would actually be negative, and we'd want to cover this part over here. If we choose a number over here that's convenient, such as 0, and we do our check, we can see pretty quickly that 10 minus 0 is going to work out really nicely. 10 minus 0 is less than or equal to 12, and certainly that works because 10 minus 0 is 10, and 10 is less than or equal to 12. So that will work. There's a little check mark right there, believe it or not. So there you go. Just be careful with those, but otherwise, now you know how to solve these inequalities. All right, nice job.